instead.
So, hello again. Good afternoon. My name is Zee Kallab. I'm a technical director. So I anticipated that we may be running a little bit behind on time. So
The cooking show.
So I
Smart man.
pre-drew a small data center, what a typical data center would look like. I just want to run quickly through the pieces to show you what I have, and then I'm going to overlay on it our solution, how we come into play, and what it's all about. So starting from the left-hand side, just have some servers, typically connected to your what I call your second layer of security through some firewalls, and jumping in front of them is your border. You have your aggregation router, then your border routers, possibly firewall front-ending and internet uplink, and then your WANs leading out to your branches. We have today we have a solution which we call a product called Interceptor. Typically, we tend to deploy interceptors in the data centers. They are more or less essentially smart load balancers. They are able to, but really they are a bridge, between going left for traffic going left and right. But the intelligence built into them is that they can identify traffic and redirect it to where we want it to go. We've been deploying interceptors for about 10 years now. So we've got plenty of experience. We know how they work. We know what needs to go. We understand data centers and what customers are looking for. So when we constructed our 5030 appliance, we wanted it to be integrated and work with the interceptor. You're probably asking yourself, well, why didn't you just, place the 5030 right at the edge, front end all the tunnels, and then bring the traffic back? We wanted our solution to be out of path. We want to be able to make it easy to deploy and very unintrusive into the existing data center traffic. If you think about it, if you were to come in and just place a device right at the edge, you're going to have to cut the traffic leading out, integrate, and now you're going to have to worry about all the routing. Am I able to receive all the routes? Am I able to terminate tunnels and go over? So we figured by going out of path onto the side, we'll be able to leverage the existing technologies that you already have deployed in the data center. Now leverage also the existing technologies, not just our existing product, but also what the customers already have deployed in their data center. We're not going to come in and ask you to go ahead and remove your firewalls, remove those border routers you already have in place. We understand you have spent enough time and configuration and all the coding that needs to be done, going through all the hurdles, and not just the routing hurdles or the layer 7 policies that you have to implement on the firewalls. The configuration part is easy. It's just that the layers above that layer 7 that come into play, which would stop you from being able to deploy an SD-WAN solution in your data center. So we will come in behind them and leverage using those components that you already have deployed. We won't ask you to throw them away. No, let's use them. We're just going to play nice with them and incorporate our solution into this. So the interceptor code that is already deployed in here, typically it serves a role as traffic is going out of the data center. It's going to identify this is traffic I want to optimize, and it's able to redirect it to a stack of steelheads sitting behind it. The same concept is going to redirect traffic in front of it to a stack of the 5030s. Okay? No.
CCP.
No, it is not. And that's the beauty part about it, is that it's a simple GRE forward out to the stack. And the reason how it does that, why does it forward that traffic? This is interesting traffic. Via SCM, we already know what the remote branches are. We know what the interesting subnets are for all the sites that are behind Steel Connect gateways. We know you are trying to go towards these subnets. So this is interesting traffic to us. It redirects it over to the stack to this cluster of 5030s. The 5030s at this point encrypt the traffic and send it on out directly over to the branch. I wish it was that simple. I don't have enough time to really dive all deep into it. But we are able to maintain which uplink you go out of and be able to associate how you're going to go, or whether you want to go over an MPLS network, whether you want to go over an internet network.
So I'm guessing we're just using traditional routing protocols then for the traffic.
Yeah,
And,
we are relying on your existing infrastructure to know how to get, essentially, hey, if I want to go to over the internet, there's a public IP address that I can reach, and this is how we change it up here in the 5030 appliances.
Is it just BGP, or are you handling IGPs as well?
It's the communication here is we do use eBGP to talk to the aggregation routers, and this is only needed as a way just to advertise the tunnel endpoints that we are using in the stack. Really, it's just a single new network that is advertised and made known to your branches via BGP, so they know how to get back to these tunnel endpoints over here. Now, the other part of that interceptor also serves, and this is part of the intelligent clustering that we have, is that when we start to receive we identify that we have all these remote sites behind Steel Connect gateways. We intelligently load balance them on the cluster of the 5030s. What we do is we form up what we call these site pools. So for example, site B1 and B3 is in a separate site pool than B4 and B2. So for example, these tunnel endpoints would end up serving out of here, and the red site pool would end up serving out of the second 5030 unit. At any point, should any of those 5030s happen to go down for out of service, somebody walks by and trips over the power cable, this tunnel endpoint moves over to the next available unit. It's highly resilient system. There is inter and intra-cluster communication, making sure that cluster tunnel endpoint is made available at all time. And we play that by using simple BGP prepending and being able to advertise where that tunnel endpoint now resides.
So that brings up a really interesting point, because I want to ask a question on that and integrating with legacy routing. So yeah, you're saying the interceptor does talk BGP and is handling BGP, or that's an ancillary router?
Not the interceptor. It's the 5030. The interceptor, all it does is just a bridge. It just sees interesting traffic and it sends it to the 5030. That's all it's doing.
So in other words, that green circle that Z drew, branch 3 has X number of address spaces, right? The interceptor knows that and says, oh, okay, you want to go to branch 3. I know how to take you there. Let me send you to the 5030 with a green dot, because that's your, and then the green dot, the 5030 box says, oh, you want to go to B3. I know how to get there. Let me stuff you into my tunnel that takes you all the way across MPLS or internet and pop you out at the local.
So the 5030 is the Steel Connect box?
That's right.
In the data center. So the question I have is, I'm integrating with a legacy routed network. I'm integrating with some kind of a BGP architecture that is not yet SD-WAN enabled. And we've had this conversation amongst this group, I think, a couple times. Can I take something like a BGP community or some other attribute and map that into a policy so that I can maybe somewhat enable a legacy routed network as it's transiting in and out of this SD-WAN cloud?
So can I answer that? So the answer is, we do not care about the legacy routing protocol that's running in the data center. We do not have to interact with that for the purposes of even adding a community. The interceptor is seeing the traffic because it's a choke point from left to right.
It's in line?
It's in line.
It's in line.
Right, but just to clarify, my question is not, I get that you've done an overlay, or you've done this to glue everything together inside the SD-WAN cloud. What I'm asking is, you have a policy that sends traffic from somewhere to somewhere.
Yeah.
If I could then extend that policy into the legacy routed network by saying, as you talk to this edge router, I want you to tag this community because I want to somewhat manually extend that policy into a BGP network and get a little bit of the benefit of SD-WAN and a legacy routed network. Is that a doable thing?
So, well, we're not doing that at the moment, in that we are intercepting the traffic. We understand the topology of where the traffic is. We're passing it to the 5030, and it then is running all the policy that Hansang was showing you there: control policy, steering policy, QoS policy. And we're manipulating it. Now, what you're asking is the reverse, as we're coming out of a 5030, you want to do something more with it, and we're not doing that at the moment, as in providing a way of identifying, say, we do something with policy and SCM and signal that to the old world by community into BGP.
Right, that's
We're
the
not
exact
doing that at
question
the
I'm
moment.
asking. Is that on the
But
roadmap?
but we could do something like that. We're not doing that at the moment,
Okay.
as in how would I say that, exporting SCM policy in a different language. It's something we could do, but it's not what we have at the moment.
Okay.
Okay, so that kind of answers the question that Yvonne
Right.
passed along from vPackets about what about routing capabilities. He said, I know OSPF and eBGP are getting released as iBGP an option. Can the Steelhead Connect replace an MPLS CE? So I guess the answer is
Yeah, so from a roadmap
eBGP
perspective,
or
we're doing all those things. So OSPF, BGP are definitely things that we're working on.
E and I both?
E and I both working on those, delivering on both of those. The key point here is that data center IGP, we are not touching anything to integrate here. We may be touching an existing interceptor, and we then are just saying, turn on one flag in interceptor, hey, there's a 50/30 cluster you need to talk to as well. And that's the only change. We have an example in a large financial. They told us to do a WAN overlay with CLI type of technology. They had to add 5,000 lines of CLI to each of the aggregation routers, and they had more than 10 data centers to do. So do the math on those number of CLI commands and the probability of failure in doing that. What we're saying here is that we may have the existing interceptor in there if it's one of our larger customers, or if it's a large data center that we're going into, it's deploying interceptor in a fail-safe manner, as in duals or quads that have a decade of working in these type of environments, and enabling a single command on each of those interceptors, telling them, by the way, there's a 50/30 cluster you need to talk to, and there's the SCM where you'll get the information you need to know about these interesting subnets that we want you to intercept, and you're done. So rather than thousands of lines of CLI, it's 4 lines of CLI, and go talk to the SCM for your policy of what you're diverting.
so that's for outbound. So we're talking about just outbound traffic here.
So there's one thing that I also want to add, because we are adding OSPF, obviously. But I would also argue, because I had a hard time transitioning my brain from my years of doing routing and switching to software-defined WAN. So technically, and I'm going to show you this in a video in just a second, if I have all my subnets and suck them all in from my CMDB, I have them all. Maybe I'm using ServiceNow, I'm using my own system, UltraPoint, whatever you name it. And I created all my sites, and I know how to get from, remember the zone? I said it's subnet, but it's more than a subnet. I know how to get from every zone to another zone. Do I care, in the world of software-defined WAN, if that happens via BGP, OSPF, IGP, or EIGRP? Do I care? All I care is that I know how to get from point A to point B, including the cloud. So routing, yes, underneath it's routing, but it became redundant in the true sense of the word. Not redundant, it's redundant, like we made it a good thing. It became redundant. You don't need it because we hid the complexity of managing. Do I care if it's type 3, type 4, type 1, type 2 LSA? No, I don't care. We hid that by saying every zone can connect to another zone, either hub and spoke or full mesh. Okay, that's a subtle concept that I want our audiences to take away.
How much time do we have?
Well, we have about 28 minutes remaining total, and about that much content. So you have some other key points you want to make?
And just for Diane's question, Denise's question, sorry, it's important to highlight the difference between a branch that is behind a Seal Connect, where we are able to replace, where we do replace the CE router, okay? We do communicate via eBGP to the provider. We have the zones behind us. SCM is aware of what is behind that SDI that just replaced the CE, and has that knowledge that it does spread it and makes it aware of all the other sites where that information is, including the 50/30s.
By the way, we said it, but we didn't explicitly call it out. SCM is Brad. Okay. Steel Connect Manager. When we say SCM is doing this, SCM is doing that, that's what we've been showing you, that central UI.
Yeah. So this is SCM stands for Seal Connect Manager. It is the brain of the entire operation.
Where are we terminating the IPsec sessions for the VPNs?
Yeah. So the 50/30s themselves, they actually terminate the tunnel sessions. Those are the tunnel endpoints where the tunnels come in.
Do I need to connect them directly to my internet segment?
You leverage your existing firewall architecture to NAT that traffic back in. Right? This is how we're able to identify. If I'm trying to reach an external IP address, my aggregate routers know, okay, I have to head out via the firewall in order to go out. SCM has done that linkage. If you're trying to go to zone B3, you can locate that behind this remote tunnel endpoint. For your return traffic, for example, use the green tunnel endpoint to come back in. If it's an internal external IP address, this is how we're able to do the steering and essentially be able to guide you over the proper path, whether it's MPLS or over the internet. How are you able to go out? Right. All by sitting to the side, away from that, without affecting the infrastructure. One of the mentions that I wanted to make, I want to make now about why interceptor, is that we're keeping the solution simple. If we're able to drop this architecture by only asking you to just enable eBGP connectivity to the SDI just to advertise that one subnet, we don't ask you to change metrics to be able to have that 5,000 lines of code just in order to influence how traffic is going to go. And we're leveraging our experience with Interceptor to find what traffic is heading out without requiring you, well, hey, just configure PBR or configure routing to move that traffic over to the 5030s. The 5030s themselves can certainly interact via BGP, and that code is built into them. But what is easier? What we have found out from our years of experience in data centers, not all network administrators are built the same. And even if you have network savvy engineers, maybe they're not interested in dumping lines of code of making these critical changes in the data center just to intercept a number of subnets.
Right.
Leverage, if you are an existing customer, you have the interceptor. That capability is in it. SCM will instruct the interceptor what those interesting subnets are. There is no change needed at all in your data center.
I agree, but I understand. The challenge that I see is this is almost never allowed in the data center today, right? NATing from the internet directly to the inside network. That's why we have DMZ.
Yep.
Right? So how do we
do not do it, ever.
Right. So,
Verboten.
so how from an architecture perspective, how are you seeing customers deploying this in the data center? I mean, how are you overcoming that security exception?
The multi-layers of firewalls that you have, right? Whether we are at the edge
draw
right
the
here.
firewall and physically where they're going to sit.
So
Understood.
Yeah.
I understand where the placement is. The reason we do DMZs is because we want to make sure that we have a blast radius of if that box is compromised, what is it going to be able to talk to? If the device is on the inside network that's fully trusted, then the blast zone for that is my entire network now, right? I'm not saying that your device is insecure. I'm saying most security,
imaginary
groups out there would never
What damage
approve
can you
this.
do?
So
Yeah.
as traffic is going to be encrypted coming in, right? And some of that traffic could also be optimized, where it renders any IPS devices blind because that traffic has already been deduped, etc. Which is why your second layer of firewalls will actually catch traffic post de-optimization outside of the tunnel. So you'll be able to catch that traffic where you are. You can treat this as if it is in the DMZ.
Right.
It is alone on the side, on an island on the side. We're using a simple GRE redirection of that traffic. We can be layer 3 hops away. It's okay, right? So all you have is just that connection right behind the firewall where you have allowed 4500 back in all the way here.
Port 4500.
But you've also the thing to remember here is that you're also compensating by the visibility in the Riverbed solution. So once you're using SCM, you've got visibility. You might be losing visibility to your legacy tools like IDSs and IPSs, which you should throw away anyway because they're hopeless, right? What you're actually doing is moving the trust boundary to the Riverbed interceptor, right? But your compensation is you now have SCM, you have centralized control, you have encrypted to the point of control, but you've also got deep visibility into what's happening. You need to, I think the thing that took me a little while to twig here was I was playing my legacy thinking, oh, my WAN edge is where the trust point boundary ends. Well, now I'm just moving my trust point boundary in a little bit deeper. What is my compensation? The answer is SCM is going to start giving me visibility into things I've never got before. Where's this traffic coming from? Who's the person? Who's the user? Blah, blah, blah.
And the key word here is where is traffic coming from? It is coming over the tunnel from those branches.
Right.
where I have this next generation firewall Steel Connect appliance deployed, where I'm able to monitor the traffic, I'm able to cut out any traffic that I do not want to see.
Your trust boundary is actually at the branch now because you're actually managing via SCM at the edge.
Well, let me ask this question. Most firewalls are BGP enabled now. So if I decide to create a security zone that's fully routed, it's got a full table, is there any reason I couldn't dump it into an ancillary security zone that is purely for secured routing transit, write those policies, advertise those networks, and then you can do your BGP magic, turn the nerd knobs, and that it gives you a security zone, but you still have your tunnel formation.
And not only that, we can do an IPsec tunnel to Zscaler, for example, right? So we can connect an IPsec tunnel to Zscaler from the branch, and I can pump traffic through there as well. I can do BGP or do an IPsec to a Palo Alto firewall, for example. We can connect to a router IPsec as well. So we're very agnostic about who we can connect to and hand the baton off to.
So you can terminate the IPsec session independently and then just pass the encapsulated traffic then back to the 5030, right?
We have an IPsec tunnel for our use.
Yep.
So let's make it easy. So what we're doing, picture's worth 1,000 words. What we're doing is we're creating a giant hose here at the branch. So what are we advertising? Tunnel endpoints. So when the traffic is coming, the interceptor says, "Oh, I know you want to go to the B3. This guy knows how to get there." Okay, so as the traffic is traversing, it's interesting traffic, gets triggered to the box 5030 here, puts it into a IPsec tunnel, magically transports itself to here, and pops out. Does that make sense? And I can do the same for the red, meaning the internet. The firewall hasn't been touched, right? So when the traffic pops out of here, your last line of defense, which is your, the IPS that you never use because you're too scared to use IPS, or the firewall, is still there. Okay? Does that make sense? So we're not compromising security. We're not saying, trust us, and punch a hole from the remote location when I just said the remote location is inherently physically insecure and pump it into your data center. Your firewall are exactly where they were before.
Yeah. Even if we do have the 1030 appliance, which is an edge device. It will sit right at the perimeter. So you can use that up to the spec limit that it can do. Right. But at the same time, if we're talking about security, you still want to require inspection of that traffic as it comes out of that tunnel, right?
Right.
You're doing the same thing. This is no different. All we are is just terminating the IPsec tunnels one layer behind and where on this firewall, you can narrow it down, only allow IPsec to these specific depths, and that's it. Okay. No other traffic will come in. You've secured it. You've locked it out.
Okay.